Hey scholars, I hope y'all are doing great today. For today's lesson, we are going to figure out how to find the volume of prisms, pyramids, cylinders, and cones. You'll have a few formulas that you need to make sure you learn, and make sure you understand the concepts behind them, and make sure you're taking good notes. Let's go ahead and get going. Alright, so let's start off by discussing the volume of prisms and cylinders. I like to lump these together because all you have to do to find the volume of a prism or cylinder is find the area of the base and then multiply it by the height of the solid. So the only difference between a cylinder and a prism really is that the cylinder is going to have a circular base. So what you'll need to do is find the area of the base, and that's going to depend on the shape of the base, right? Like you'll have to use the area of the circle formula for the cylinder, and then whatever type of prism it is, like in this case it's a triangular prism, you'll have to use the area of a triangle formula to find the area of the base and then multiply it times the height. So in this case we have B, uppercase B, that's the area of the base. So because it's a triangular prism, the area of the base is going to be 1/2 base times height. Now this little b is going to be like the base of that triangle. Here we're trying to find the area of that triangle. So like b times height. There, okay? So you'd have to find that. And then you would substitute in that formula. So we'd have volume equals 1/2 base times height times this h is going to be the height of the solid, right? So make sure you're understanding that. Find the area of the base and then multiply it times the height there. Now we have another formula for volume of the cylinder. It's really volume equals base times height, but the area of the base is going to be pi r squared, because that's how we find the area of a circle, pi r squared. So you have that other formula, which is essentially the same as this. It's the area of the base times the height, pi r squared times the height. So that's the volume formula for a cylinder. But for prisms and cylinders, just remember the main concept is you find the area of the base and you multiply it times the height. That's it. So let's apply those concepts here by working some problems. Alright, so let's try this. This says to find the volume of each solid and to round to the nearest tenth if necessary. Okay, well, here we have what looks like a rectangular prism. Okay, so we want to find the area of the base here first and then multiply it times the height, right? So volume is equal to the area of the base times the height. So what's the area of the base of the rectangle? What are we going to do here? Well, we're just going to say length times width, right? For a rectangle, this rectangular base, it's going to be length times width, right? So the length would be 12, the width would be 10. So B is going to equal 10 times 12, which equals 120. Here's it, centimeters squared, right? Because if we're saying 10 centimeters times 12 centimeters, centimeters times centimeters is centimeters squared. So remember, when you find area, the unit is going to be squared because you're multiplying that unit times the unit, centimeters times centimeters. Alright, so we've got the volume equals the area of the base, which is 120 centimeters squared, times the height, which is 8 centimeters. Okay, so now we're just going to say 120 times 8. That's going to give us 960. And then centimeters squared times centimeters, well, that's going to be centimeters cubed. When you have volume, when you're finding volume, the unit is always going to be cubed. So that's our final answer, 960 centimeters cubed. Basically all we did here was we said 10 times 12 times 8. That may not work for every type of prism, but it definitely works for a rectangular prism. So let's go ahead and move forward. So let's find the volume of this cylinder. So remember, the formula is volume equals the area of the base times the height. Well, we got to find the area of the base. That base has a radius of 8 centimeters. So R equals 8 centimeters. So the formula that we're going to use is pi r squared. That's the area of a circle. That's the formula for the area of a circle. That should look familiar to you. So base is pi times 8 centimeters squared. So substituting 8 in for r. All right, so we're going to get, let's square, what's 8 squared? It's going to be 64, right? We're going to say 64 pi centimeters squared, okay? You might have thought to write it as pi times 64 centimeters squared. That would be fine, but we just tend to like to write that number first, 64, then pi centimeters squared. That's how you'll tend to see it. So anyway, let's substitute in 64 pi centimeters squared for b, because we found the area of the base. 64 pi centimeters squared. And then the height. How tall is that cylinder? It's 12 centimeters, isn't it? 12 centimeters. So we get V equals 64 times 12 is 768. And then don't forget pi. Don't lose pi. It's easy to forget to include pi in this. And centimeters squared times centimeters is centimeters cubed. So the volume equals 768 pi centimeters cubed. Now this says to round to the nearest tenth if necessary. I'll show you how to do that in just a second. But I like to leave pi in the answer because that's as precise as it can be. Remember, pi is this kind of crazy number that never repeats. It's just a decimal that goes on forever. So if we just leave pi in the answer, that's actually as precise as it can be. Now, we can substitute 3.14 though in for pi. Remember, pi rounds to about 3.14. So all I'm going to say here is 768 times 3. Put that in my calculator. I get 2,411.52 centimeters cubed. But it says round to the nearest tenth. 5 is in the tenths place. So let's look at the 2. Is it going to stay at 5 or round up? It's going to stay at 5 because 2 is closer to 0 than it is to 10. So 2,411.5 centimeters cubed if you were to write it as a decimal. And let's say it's about, let's give a squiggly equal sign because I rounded. It's approximately 2,411.5 centimeters cubed. That's the volume of that cylinder. So these are two different representations of writing that volume of the cylinder. Here's an exact way, leaving pi in your answer. Here's an approximated rounded way by substituting in 3.14. All right, let's move forward. All right, now let's discuss the volume of pyramids and cones. I like to put them together because you're essentially doing the same thing that you do with a prism or a cylinder, finding the volume in that way, but then you're going to multiply them by 1/3. So you're going to take the area of the base, multiply it times the height, but you're also going to multiply that by 1/3. So the volume formulas for pyramids and cones are 1/3 equals the area of the base times the height. All right, and obviously the difference between a cone and a pyramid, we know a cone has a circular base. So here's a little trick. Here's what I prefer to do. Instead of multiplying by 1/3, I like to divide by 3. I like to find the area of the base times the height and then divide by 3. Because check this out. If you say 1/3, let's just say 1/3 times 6, okay? Well, I'm going to rewrite 6 as 6 over 1. 1 times 6 is 6. 3 times 1 is 3. Well, doesn't this end up looking like 6 divided by 3? Well, what is 6 divided by 3? It's 2, right? So 1/3 times 6 equals 2. Or instead of just multiplying by 1/3, just say 6 divided by 3 equals 2. So here's what I'm trying to say. just find the area of the base times the height like you would a prism or a cylinder, and then divide that answer by 3, and you'll get the volume of a pyramid or cone. Okay? So let's move forward and apply that as we work some problems. All right, now this says find the volume of the solid. We'll round to the nearest tenth if necessary. Okay, so remember what we're going to have to do is say the volume equals 1/3 times the area of the base times the height. Now remember, like I said, we can just find the area of the base, multiply by the height, and then divide by 3. So let's do that. Let's find the area of the base first. Now, what is the shape of the base of this pyramid? We have a pyramid here. Well, it's a trapezoid. Now, there's a couple different ways we can find the area of the trapezoid. So we can say that the area of the trapezoid is, we can say 1/2 times the times base 1 plus base 2 times the height. Okay. Maybe you've seen it as base 1 plus base 2 divided by 2 times the height. That's the area formula for a trapezoid. You may want to write that down. All right, so now let's substitute in for base 1 and base 2 in the height. So the area of the trapezoid is 1/2 times base 1 is 9, base 2 is 18, and the height of that trapezoid is 6 meters. We get, let's just say 9 plus 18, that's going to be 27, right? 27 times 6 is 162. 1/2 of 162 is 81. So the area of the base is 81 and then meters squared, right? Meters squared. Okay, so we get the area of the base is 81 meters squared. Now let's take that 81 meters squared and we'll substitute it into the volume formula. So we get V equals 1/3 times 81 meters squared, and then the height of this pyramid, the height, so going from that trapezoid all the way to that point is 10 meters. So we're going to take the volume, or the area of the trapezoid and multiply it by the height, which is 10 meters. So we're going to say times 10 meters. H is 10 meters. So we just substitute in there. So we're going to get volume equals 1/3 times 81 times 10 is 810. Meters squared times meters is meters cubed. 1/3 of 810. Remember, we can say 810 divided by 3. Divide 810 by 3, you'll get 270 meters cubed. 270 meters cubed. All right, so that's the volume of that trapezoidal pyramid. Let's move forward and find the volume of this cone. Last problem that we'll do. Follow along with me. All right, so remember the formula for cone is 1/3. That volume formula is 1/3 the area of the base times the height. Now, the base is a circle, right? Now here we're given the diameter. This is the diameter, this whole length from one point of the circle to the opposite point is the diameter. So we're given the diameter. Now, remember, the radius is 1/2 of the diameter. So what's half of 18? That's going to be 9, right? So the radius is 9 meters. So when we're finding the area of the base here, we use pi r squared, right? Well, don't substitute 18 in here. Remember, if you're given the diameter, you've got to find the radius. So we're going to say the area of that base is pi times 9 meters squared. 9 squared is 81. Don't forget pi. So 81 pi meters squared. Okay? So we've got volume equals 1/3 times 81 pi meters squared. And then what's the height of that cone? That's 8 meters, isn't it? So we're multiplying it times 8 meters. So we get 1/3 times 81 times 8 is 648 pi meters cubed. Meters squared times meters cubed, right? So what are we going to do with that 648? We're multiplying by 1/3, right? So divide it by 3. 648 divided by 3 is 216. And then pi meters cubed. So that's an exact answer. If you are to substitute in 3.14 for pi, let me do this on my calculator real quick. So 216 times 3.14 is what I put in my calculator. So the volume is about, we get 678.24, which is going to round to 678.2 meters cubed. And then there's our final answer as an approximated form, substituting in 3.14 and then rounding to the nearest. So if that lesson was helpful for you, if you have any questions, I encourage you to rewatch certain parts, but make sure you come to class prepared and ready to work. Good stuff today. Thank you, collegiate scholars.